All right, we're going to tackle how to find the domain of a function from its equation. And just to remind you of what domain is, it is the set of inputs for a function that yield outputs. And when we're talking about functions in algebra, we're talking about real number inputs and real number outputs. That means we don't want any imaginary numbers. Okay, so keep that in mind. Now, I have tried teaching this concept the traditional way, and it hasn't been successful over many years. So the way I'm going to present this is using something called critical numbers, which are actually really useful throughout much of algebra, trigonometry, calculus, and so on. So this method of doing it can be applied lots of other places, and I think it's actually very visual. I've had a lot of good feedback from students about this way of doing it as well. So here we go. So the main idea that we're going to use here is identifying critical areas. If we're wanting outputs that are real numbers, we have to think about calculations that won't give us real numbers. And I already mentioned imaginary numbers. That's one way that could happen. So we're going to look at two critical areas here. One of them will be, how do you get imaginary numbers? And you can only get imaginary numbers if you have even roots. So what I mean by that is square roots predominantly, but it could also be fourth roots and sixth roots and eighth roots, okay? Odd roots will never give you imaginary numbers, so we're not worried about those. So even roots are a critical area. Now, what's another calculation that won't give you a real number? Well, there's one calculation that doesn't even give you a value, and that is when you try to divide by 0. So another critical area is going to be denominators. We have to make sure that we don't divide by 0. Okay, so those are our two critical areas that we'll focus on throughout this video. And knowing those two areas will help us identify critical values or critical numbers, okay? So let's do some examples here. Find the domain. And we're going to write our domains in interval notation, all right? Find domain. So example 1, or the first example, will be the function f of x equals the fraction, the rational function, x minus 3 over 2x plus 1. Okay, so that's the function we want to know the domain. We want to know what inputs will give real number outputs. What x values will let us have real number outputs? So we look at this and we ask, are there any critical areas in this function? Any places where we need to be worried about? And yes, we have a denominator. So our critical area is this denominator. And now I'm going to talk to you about how to find critical values, okay? So to get critical values, any critical values, you take your critical areas and you set them equal to 0. All right? And so the reason we set equal to 0, and I'll try to be, I don't want to get terribly technical here, okay? But the idea is 0 is the number that separates the negative numbers from the positive numbers, right? And so it is sort of that threshold. On one side, it's positive, on one side, it's negative. So that's really the main idea here, and you'll see how that plays out. Now, critical values are x values. So we need to solve this for x, and when we solve this for x, we get negative 1/2. That's our only critical value. Now, what we're going to do with this is we're going to cut the number line. We're going to look at our domain visually on a number line, and we're going to cut that number line at the critical value. So I'll do that over here. So these are the x values, right? And x equaling negative 1/2 is our only critical value, so I've sliced my number line right there. Now, when I've cut my number line, I've cut it into 3 parts. Obviously, one part is negative 1/2 itself, that critical value. But by default then, I've got everything to the left of negative 1/2 as another part, and everything to the right of negative 1/2 as the third part. Okay, so what we have to do is analyze this number line piece by piece and find out which pieces are in the domain of this function. So here's how we're going to do it. Let's begin with -1/2 itself. I want to look at all the x values on this number line and decide if they can be plugged into this function for x and yield an output, okay? So let's look at -1/2 first. If I look at x equaling -1/2, I already know it's going to make the denominator equal to 0. That, right? It says x equals -1/2 is the solution to the equation 2x plus 1 equals 0. So that means this critical value makes my denominator 2x plus 1 equal to 0. You cannot divide by 0. So I already know -1/2 is not in my domain. So what I'm going to do is put an open circle on that, because that means we don't include that point. And I'll just write above it, we're not including it because that x value causes our function to divide by 0, which will not yield an output, okay? So I know this number is not in my domain. If I look at numbers to the left of -1/2, well, the only critical area I have here is this denominator, and I know that if x is anything but -1/2, meaning even anything less than -1/2, my denominator won't be 0. So all of those numbers, all of those x values are just fine in my domain. So I'm going to shade those. These x values I can plug in because they will not make my critical area, my denominator, 0. Okay? And then similarly, all the values bigger than -1/2 will also work for x. Whenever we have a denominator, we just have to make sure it's not 0, okay? So this is my domain. So if I write that in interval notation, it looks like this. -∞ to -1/2 union -1/2 to infinity. And that's the domain of that function, okay? So let's continue this process with a variety of functions here using this concept of critical areas and critical values, and then setting up this number line representation of our domain. So the next example is f of x, we're still finding domain, still the same instructions, equals 3 minus the 4th root, make sure you put your 4 in the crevice of your radical here, it means 4th root, of 5 minus 6x. Okay, and so in this case, the critical area is what's underneath the even root. So this guy right here could cause problems because I know that if the thing that's circled in blue is negative, those numbers won't be in my domain because even roots, you may want to write this down, even roots of negative numbers do not output real numbers. Okay, they output imaginary numbers. You should be familiar with that from previous algebra courses, like intermediate algebra or algebra 2. Okay, so what we're going to do is to find my critical values. I only have one critical area. I'm going to set it equal to 0, just as we did before, and I'll solve this for x, and I get positive 5/6. So I get one critical value. I'm moving quicker now because we understand all the basics, and I want to show you how fast this really is. So I cut my x number line at 5/6, and then again I've got 3 regions I have to evaluate. Now, let's look at if x is 5/6. I know that if x is 5/6, that 5 minus 6x is 0. You don't automatically exclude it whenever it makes it equal 0. You do that if it's a denominator, because you can't divide by 0. But when you have even roots, you can actually, if 5 minus 6x is 0, you can actually take the 4th root of 0. You can't divide by 0, but you can have a 0 under an even root. So 5/6 actually works in this case as part of our domain. So I'm going to shade that value to include it in my domain. And if you want to test this, plug 5/6 in for x into this function, right? Type all of this into your calculator and hit enter, and you'll get a number, a real number output, meaning that this number's in your domain. All right, now, if we look at numbers less than 5/6, any number you want. So for example, 0 is over here. If we plug in 0 for x, you get 5 minus 0, which is 5. Well, you get a fourth root of a positive number. You can take even roots of positive numbers. So that indicates that numbers over here are in the domain. You can take even roots of positive numbers. Now I picked 0, but you could pick any number. Pick negative 1,000 for x. Be really extreme, right? If x is negative 1,000, this turns into 5 plus 6,000, which is 6,005. That's a positive number, and you can take an even root of a positive number. So this half of the number line works. Now let's look at numbers bigger than 5/6, like 1. 1 is really close, but it's bigger. If you plug in 1 for x, 5 minus 6 is negative 1. Now you've got a problem because 5 minus 6 is negative 1. You can't take an even root of a negative number and get a real number output. So that implies that these numbers over here don't work. And anytime I have a region that I mark as not working, I like to justify it. So in this case, I'll say it's because we have a fourth root of a negative number, which doesn't work. And again, I chose 1 as my x value, but any x value over here you could test, like positive 1,000. If you plug positive 1,000 in for x, you get 5 minus 6,000. That's still negative under the fourth root. So now our domain is just this one region, negative infinity to 5/6, including the 5/6. And that's our domain. All right. Let's look at another example. So we've done a fraction, we've done an even root. Remember our two critical areas. Denominators, even roots, right? Okay, next function. F of x equals x squared plus 9x minus the absolute value of x. It's kind of an unusual function. It looks kind of strange. So the way we tackle this, remember the instructions are find the domain. The way we tackle this is we look for any critical areas. Even roots. We don't have any even roots here. We have an even power. That's not the same thing as an even root, like a square root. So no even roots. We also look for denominators. Well, we don't have any denominators either. There's no critical areas. That means that there's no potential of having a faulty calculation. No matter what we plug in for x here, we can deal with it. We can calculate an output. So the domain here is every number on the number line, which we write as negative infinity to positive infinity. There are no critical values here because there are no critical areas. So that's our domain. And oftentimes, most functions will have a domain of all real numbers, negative infinity to infinity, because the only time you're going to run into issues is if you have critical areas, okay? All right, let's try a more advanced example now. You'll likely see this later on in a college algebra course. So let's kind of work at it now. Let's look at the function. It's a fraction. The numerator is x plus 2, and the denominator itself also has a fraction. So x over x minus 3 plus 1. That's our denominator. So we have to identify the critical areas first. Well, there are no even roots, so no problem. But critical areas could also be denominators. Well, clearly x minus 3 is a critical area. It's a denominator, so we'll set it equal to 0, which means that x equals 3 is a critical value, okay? However, that's not the only denominator. All of this is also a denominator. So that's going to yield a critical value as well. So we have to set all of that equal to 0. And you have to know how to solve this kind of equation. Again, I'm referencing back to intermediate algebra, algebra 2, something like that typically, is where you'll learn how to solve an equation like this. It's called a rational equation. It contains a rational expression. So lots of ways to do this. What I'm going to do here is subtract the 1 over. And then I'll multiply both sides by x minus 3 to get rid of this denominator. So when I multiply the left side by x minus 3, that leaves x on the left side. And when I multiply the right side by x minus 3, I just get negative 1 times x minus 3. And now I'll distribute my negative 1 to get negative x plus 3. And then I'll add x over to give me 2x. And then divide by 2 to get x equals 3 halves. So I've got two critical values here, 3 halves and 3. So now I'm going to visualize my domain on a number line. I will cut my number line at my two critical values. The smaller one is 3 halves. That's the same thing as 1.5. So I'll put it to the left of 3. And now I have to evaluate 3 halves and 3, so that's 2 pieces. And then I have to evaluate the 3 regions in between, okay? So if x is 3 halves, we already know that everything in red here turns to 0, which means we would be dividing by 0. So I know if I plug in 3 halves, I'll be dividing by 0. I don't want that, so I'm going to exclude that number from my domain. If x is 3, I know what's circled in blue will be 0. And again, that means I would be dividing by 0 in this fraction. I don't want that either. So I'll exclude that. And since we don't have any even roots, I know that those are the only two values that will cause division by 0, meaning that every other number on the number line is a valid input. So our domain is the union of these 3 intervals. Negative infinity to 3 halves, union 3 halves to 3, union 3 to infinity. And that's the domain of that function. It's a kind of a complex example, but you can see the beauty of finding your critical areas, setting them to 0, and then using those to cut your number line at your critical values. Now I want to be very complete here, so I've got a couple more examples. Let's look at f of x equals, and we'll do another fraction. Most students struggle with fractions the most, so I'm kind of emphasizing them. So we've got 5x minus 1 over the square root of x plus 2. Okay? So now we're still finding domain. I've got denominator and an even root. A square root is an even root, okay? By the way, if this were an odd root, it wouldn't be a critical area because odd roots do not yield critical areas, like cube roots and fifth roots, etc. Okay? All right, so we know that since x plus 2 is under a square root, it's going to give us a critical value of, and in this case it's negative 2. But then we also have a denominator, which is the square root of x plus 2. And if we solve that, we also get, so square both sides to get rid of the square root, and then subtract 2, just a little review there. So it actually yields the same critical value, okay? And you may see that initially. Personally, I wouldn't set up both of these because I could tell right away that negative 2 is a critical value. So this part here is not necessary, but you may want to write it down if you wouldn't have thought of it, okay? So negative 2 is our only critical value. So we cut our number line at that value, and then I ask myself, okay, if x is negative 2, well, I already know that that means I would be dividing by 0. So I know negative 2 is not in my domain. Then I look at numbers to the left of negative 2, like negative 10, for example. And if I plug negative 10 in for x, and again, I'm only focused on this stuff that's circled, right? Because the numerator is not a critical area. I can plug anything into that in this particular problem. But if I plug negative 10 in for x, negative 10 plus 2 is negative 8. Who cares about the 8? It's negative. And it's not that I'm dividing that causes the problem. It's the fact that I'm trying to take the square root of that negative number. So if I plug in numbers over here, I get a square root of a negative now, which I don't want. That gives me imaginary outputs. So those numbers are not in my domain. If I look at numbers bigger than negative 2, like positive 10 or 0 or 1,000, whatever, plug in any number over here for x. Let's use 1,000. 1,000 plus 2 is positive. I can take the square root of a positive number and I can divide by that positive number. So that doesn't cause any trouble at all. So all of these numbers here are in my domain. And so now I'm looking at a domain from -2 to infinity, but not including the -2 because it caused division by 0. Okay, fantastic. Great examples so far. Now let's consider flipping this function, taking the reciprocal of it, and see how that changes our domain. So the next function is f of x equals the square root of x plus 2 over 5x minus 1. So in this case, I have a denominator, that's a critical area. So I set that equal to 0 and solve for x. So I know that 1/5 is a critical value. But I also have a square root. It's in the numerator, but because it's a square root, it's still a critical area. So I set that equal to 0 and solve. Again, square both sides to get rid of the square root and then subtract 2, and you get -2 as a critical value. So we have two critical values again. We cut our number line. -2 comes first on the number line, and then 1/5 comes later. Make sure you get those in the right order. It can wreak havoc on your, when you go to look at your number line, it could really confuse you if you have those in the wrong order. All right, let's look at -2 itself. If I plug -2 in, I already know that it's going to make my numerator 0. And that's fine. I can take the square root of 0, and I'm not dividing by it, so it's okay. So I know that -2 is a valid input to this function. And you can test that out. Plug -2 in for x into all of this formula, use your calculator, and you'll see that you get an output. It's going to be 0, okay? 0 is a real number output. So -2 is a valid input. 1/5, I already know that if I plug in 1/5, it's going to make the blue guy equal to 0, which I know I can't divide by 0, so I don't want 1/5 in my domain because it causes division by 0, okay? Now we've got to look at the three regions. Let's look at if I plug -3 in for x, I know it's not going to make my denominator 0, so that's not an issue. But if I plug -3 in for x up here, -3 plus 2 is a negative number, and I can't take a square root of a negative. So if I look at this region, I get a square root of a negative, it's not part of my domain. But if I go to the other side of -2, maybe 0, which lives between these, that's going to give me a square root of a positive number and not make my denominator 0. So all of those numbers work. And similarly, numbers bigger than 1/5, when I plug those in, I will also get a positive under my square root, and my denominator is not 0, so all of those numbers are in my domain as well. So the domain is the union of these two intervals. -2 to 1/5, including the -2, union 1/5 to infinity. And that's the domain of this function. So I tried to do several examples here of domain, how to identify critical areas. That's the big thing, understanding that denominators and even roots, they're the troublemakers, right? So let's hone in on those to identify our critical values, and then just visually break up the number line so you can evaluate region by region to determine what your domain is.